In this video, we are going to be discussing rotations. So, a rotation is just a transformation that turns a figure around a fixed point, and that point is called the center of rotation. And for all intents and purposes, a rotation is basically just a spin. So if I make a triangle here and I spin it, that is a rotation. All right, so we're going to be using the origin, which is the point 0, 0, as our center of rotation. So all of our points are going to be spinning around the center of the graph. And rotations can have two directions. They can be clockwise or they can be counterclockwise. So a clockwise rotation is obviously the direction that a clock turns. And another way of thinking about it, if we look in the coordinate plane, if I make a really bad coordinate plane, clockwise is also sort of can be seen as a right turn. And counterclockwise is going the opposite way of the clock, or we can think of that as a left turn. All right, so clockwise and counterclockwise are our two directions. And along with directions, there's going to be a certain amount that a rotation is going to happen. So for our rotations, we're always going to be doing our rotations in multiples of 90 degrees. So the way this works is if you're doing a 90-degree rotation, it moves your shape exactly one quadrant. Okay, so the coordinate plane is split up into 4 quadrants, and going 90 degrees moves you one quadrant. For example, if I start with triangle B here, and I move 90 degrees clockwise, that's one quadrant clockwise, and that puts me at triangle C. All right, that's 90 degrees. Similarly, 180 degrees, well, 180 is just 2 times 90, so that moves you 2 quadrants. So you go 1, 2 quadrants, and if you go 180 degrees clockwise from triangle B, you end up at triangle D. And finally, if you do 270 degrees, well, that's 3 rotations. And now we end up from B to A. And then 360, well, that's 4 quadrants, or really that's just back to start. Right? So that's how the degrees work. And they can go in either direction. So if I say moved 90 degrees counterclockwise from B, well, that's 90 degrees, and it makes it one quadrant, and it's counterclockwise. That puts me at A. Right? Notice that that is the same thing as if I went 270 degrees clockwise. All right? And the only rotation that you don't have to give a direction on, clockwise or counterclockwise, is the 180-degree rotation. Okay, for 180 degrees, you don't need a direction because it doesn't matter what way you go, you end up in the same point. For example, if I go 180 degrees from A, that's 1, 2 quadrants. So if I go 180 degrees clockwise, I end up at C. But if I go 180 degrees counterclockwise, 1, 2, I still end up at C. Notice the direction doesn't matter for 180. It also doesn't matter for 360, but for 90 and 270, the directions do matter. Okay, so how do we do this with points? Well, every time a point is rotated 90 degrees, the coordinates are going to switch from A to B. And the signs of the are from AB to BA. They're just going to switch places. And the signs, positive or negative, of the coordinates depend on what quadrant the point is in. So if we're in quadrant 1, they're both positive. If we're in quadrant 2, the x is negative and the y is positive. If we're in quadrant 3, they're both negative. And if we're in quadrant 4, the x is positive and the y is negative. So the way this works is, for example, say I have this point. Say I have this point 2, 7. And 2, 7's up here in quadrant 1 somewhere. And I rotate it 90 degrees clockwise. I'm just going to use CW for clockwise. Well, I know that moves me one quadrant down here to the right. All right, one quadrant clockwise. That puts me here in quadrant 4. Now, every time I move 90 degrees, these two switch places. So now I've got 7, 2. And now I look. In quadrant 4, my x is positive and my y is negative, so I just put the negative here. If I was to rotate it one more 90 degrees, so now I'm at 180 degrees total, these switch back, so now it's 2, 7, and because I'm in quadrant 3, both of them are negative. Finally, if I go one more, now I've gone 90, 180, 270. Well, now I'm in quadrant 2. These switch back again, so now I'm at 7, 2. And here my x is negative and my y is positive. So this is how we're going to do rotations. So let's take a look at an example. Example 1 says rotate the given point 90 degrees clockwise. And let's give this a name. Let's call this point A. All right. Let's write down our coordinates here. Point A is at 1, 2, 3, 4, and up 1. So 4, 1. And we're going to go 90 degrees counterclockwise. So when I'm doing this, first thing I want to do, draw myself a little arrow that tells me I'm going 90 degrees. That's over one quadrant, and my direction is clockwise, so I know I'm going over here. All right, 4, 1 are my original coordinates, and those are going to switch place, so now I'm at 1, 4. All right, and because I'm in quadrant 3, that tells me, well, my x's are negatives and my y's are positive, so I'm at negative 1, 4. Negative 1, 1, 2, 3, 4. So there's A prime right there. Okay, so all I did, I used my degrees and my direction to figure out that I'm going to be in this quadrant. Because I moved one set of 90 degrees, my x and y just flip places. And then I used the fact that I'm in this quadrant, and I know that over here, x is negative, y is positive, to see that it's negative 1, positive 4. All right, let's take a look at another example. It says rotate this triangle 180 degrees. Now remember, 180 degrees, it doesn't matter which direction we go, we're going to end up in the same place. So if I think about this, I know I'm going to go 90, 180. So I'm going to end up over here. Now notice I have these 2 points, N and P. They're both in the same quadrant, so they're going to end up over here. We'll deal with M here in a minute. All right, so let's take a look at N. N is at the point 1, and then 1, 2, 3, 4, 5. So this is at 1, 5. Now every time I move 180 degrees, I know that these two flip places. So if I'm at 1, 5, down here I'm at 5, 1, and over here, now I'm back at 1, 5. And I know that in this quadrant here, both the x and the y are negative, so I'm at negative 1, negative 5. So 1, 2, 3, 4, 5. There we go. That's N prime. Now I can do the exact same thing with the point P. So P is at 1, 2, 3, 4, 5, 6, 7, 2. All right. I know it's going to go 7, 2. Here it's 2, 7. And here it's back to 7, 2. Once again, both x and y are negative, so it's negative 7, negative 2. So 1, 2, 3, 4, 5, 6, 7, and down 2. There's P prime. Okay, now I need to do M. Well, M is going to also move 180. So let's see, that's 1, 2. So it's down here in quadrant 4. All right, its coordinates are negative 3, positive 2. So as I move, here's 90, it switches back to, it switches to 2, 3. And then back over here, it switches to back to 3, 2. And in quadrant 4, I know my x is positive, my y is negative, so my coordinates are going to be 3, negative 2. So 1, 2, 3, and down 2, there is M. prime. So now if I connect my dots, I'll see that I've rotated my shape 180 degrees. So that's how we do this with rotations. We use our quadrants to figure out where we're supposed to be. Okay, let's take a look at one more example. It says rectangle ABCD has vertices at 416, 412, 812, and 816. We want to find the coordinates if ABCD is rotated 270 degrees counterclockwise. So let's think about this. All right. So if we look here, we're going to do this with 4 points. All of them are in quadrant 1. If we think about their coordinates, think of them as A, B. And I'm going to go 270 degrees counterclockwise. So 1, 2, 3. Okay. If I move 90 degrees, the coordinates switch to BA. 180, they switch back to AB. 270, they switch back to BA. And in quadrant 4, the x is positive, the y is negative. So if I think of this as A and B, well, 416, they're going to switch places. 16, 4, and I want this y value to be negative. Same thing, 12 and 4 switch places. Want the 4 to be negative. 12 and 8 switch places. Want the 8 to be negative. And 16 and 8 switch places. And I want the 8 to be negative. That's exactly how we do it. We just draw this little diagram and it helps us figure out exactly where our points are going to go. So there you have it. You know all you need to know about rotations. So here is a problem for you to try. It says triangle ABC has vertices. Oh, that got messed up. Triangle ABC has vertices at 1, 4, 3, 7, and 6, 0. If the triangle is rotated 90 degrees counterclockwise, what are the coordinates of A prime, B prime, and C prime?